Quartic graphs. Now to draw a quartic graph, I'll recognize by a polynomial to the 4th degree. So that 4 tells us this is a quartic graph. Now to draw this, something like this is not required in our curriculum, but we still need to be able to draw it. So the only thing that we will look at is we'll look at a graph that's in the form of y equals a x minus b, x minus c, x minus d, x minus e. This will be quartic because x times x times x times x will give us to the power 4, and therefore it's a quartic graph. Now, if I have a greater than 0, which means positive a, I have to finish my graph at where y is positive at up there, which means our graph's going to have a shape like that. If a is less than 0, negative a, it means that my graph needs to finish where y is negative, so it's down here, which means it's going to look something like that. Now, we are not capable of telling where the turning points are. The only thing that we can put in is we can put in the intercepts with the x-axis and the intercepts with the y-axis. So if I have to redraw that, my graph for this function, and I'm just going to underline that with another color. So this graph would look like this, and let's assume a is positive. So a is greater than 0, then I'm going to have something like that, and we will say that this is point, that's B, that's C, that's D, and that is E, and I can calculate this value here by multiplying, say where x is 0. There might be things happening. There's few things that can happen. A factor may occur twice. In other words, we can have something like y equals a x minus b, x minus c, or x minus d squared. If there's a d squared, it means there's a turning point on the line, which means that this graph of ours can either look like this. If a is positive, it will look like this, but then there will be a turning point on the graph. Oh, that's one big fat lie. So we'll just do this. I will redo it. So for this graph, if it's positive, I need to end up there, which means I have to start here. So it will come down, go over, turn on the graph, and goes up and go up. So there will be, this will be B, this will be C, and a turning point there will be D, because it's D squared. If I was negative, it will be the other way around, like this one over here. So let's just finish it. Let's play. So it will look something like that. We will be able to say that this is A, that is B, and that is, B, C, and D. But we will also be able, but we won't be able how, if this thing looks like this, or if it looks like that. So we don't know how deep it goes. Our next one, that is when we have a double factor and we have a turning. We can have a triple factor. If we have a triple factor, so if we have y equals, and I have a x minus b, x minus c cubed, and I'm just going to assume a is positive, which means I'll have this shape. I need to finish there. This cube function will give us a point of inflection. So it will start at the top, it will turn there, and we will have a point of inflection on my y-axis. So on there, I'll have a point of inflection. This will be point B, and that inflection point will be point C. If I was negative, it will come in the opposite direction, which means it will come down, it will go up, go through B, a point of inflection, and come down. That will be B, and that will be C. This is if A is positive, this if we have a negative A. The last case is where we have just one cubic function. How weird. Y equals A times x minus 4, x minus b to the power 4. And all we have, if A is positive, we will have, looks like a fat parabola. If A is negative, it will be the other way around. So it will look like this.